Hi, I'm John Ingalls. Thank you for coming today. Welcome. I have the distinct privilege to introduce our next speaker, Joe Olson with United Airlines. They're going to talk about their big data journey. Hope you enjoy. And here's Joe.
Okay, my name is Joe Olson. I work for United Airlines. My title is the Senior Manager of Big Data Analytics. Talk today will be a little bit about how we're doing on our big data journey and how we use the Hortonworks platform in our day-to-day operations. Okay, so the agenda, we'll talk a little bit about what the data landscape at United looks like. We're an airline, typical airline, so we've got a lot of data, a lot of problems with that data. We'll talk a little bit about what we're up against. What our current environment looks like, what our target environment we're working towards looks like, and then we'll go over a couple quick analytics use cases that we're working on to highlight the advantages of the Hortonworks platform we're using. So about United Airlines, we've got 750 aircraft with another 250 on order. So when you have that many aircraft, you've got a lot of supply chain issues. So that's the takeaway there. We moved 148 million passengers last year. In order to do that, we have to have a public-facing website that we sell inventory to. We've got a mobile app that a lot of people are familiar with. We sell inventory that has got the price of the inventory changes with time. So it swings with demand. The price of a seat will fluctuate. The price of a seat will fluctuate based on geospatial data. So a window seat will be worth more than an aisle seat. So this isn't necessarily Home Depot where everything is priced the same. All rakes, the same type of rake is priced the same way. The inventory, as it changes price. We've got a loyalty program, so we do a lot of surveys with our customers. We also do ancillary sales. We sell Wi-Fi, we sell snack boxes, things like that. On the operations side, we've got 4,500 daily departures, so all the scheduling problems with coordinating a schedule of that magnitude, anything involving the weather, any kind of route planning, all that comes into play. Airport side, we've got baggage claims, check-ins at airports. All those people have to get checked in. Their baggage has to be dealt with. And in addition to that, we've got 86,000 employees, so all the problems with coordinating a workforce, all the scheduling, all the pay issues, all that. So with all that, we're really a data science dream. Every data science problem that you hear talked about here at the different industries, we have all of them. The loyalty issue, the operations issue, all the time series data, it's all in one place at an airline. Further compounding the problem, the future is always changing. So bookings are constantly streaming in. If you want to do any analytics on that, your analytics program has got to be able to support rapidly changing data. It's not immutable like in a lot of cases. In retail, if something's sold, the immutability of that is pretty solid. You may have returns, but in an airline, the future is constantly in motion. So a lot of these things should appeal to any data science out there. So the goal of all this is fourfold. Everything we do falls into one of these four buckets, and this is the analytics team's charter. First and foremost, improve the customer experience. So all this data that's being fed into our platforms, different platforms for analysis, is primarily to improve the customer experience. So how can we reduce friction when booking a reservation, maneuvering through an airport, all those things that cause passengers stress? How can we deliver a consistent message across all these different channels? We've got a website, a mobile app, all those things I talked about previously, social media. How do you deliver a constant message to your customer base over all those channels? In addition to customers, we also try to improve the employee experience. So how can we use all this data to properly inform employees of the situation and what's going on at the airline? And how can we do that quickly? What are we learning from our customer base about what's working and what's not? So when customers report things that are going on, how can we gather that information and feed it back to the employees so they can adjust what they're doing appropriately? Revenue generation, I think that motivates everybody for doing data analytics. How do you improve revenue based on personalization. How can we personalize experience with our customers so that they offer them offers that they have a high probability of accepting? And are they in line with the rest of the industry? And then finally, improve operational reliability. Since we've got such a gigantic fleet that's always in motion, how can we better prepare for operational interruptions such as weather? So when a storm hits, what do we do and how do we do it? How can we manage the fleet better and ensure spare parts are where they need to be? So all the supply chain analytics are out there apply to our airline as well. So here's some customer experience ideas that the industry at large is playing with. I threw a couple of them up there. I've been gathering different types of ideas in the airlines that are working on them. So there's some crazy ideas out there. There's some reasonable ideas out there. A flying nanny, okay. Maybe your customer feedback says that's a service your airline needs to offer. I don't know. But this is the kind of information, the kind of business decisions that come out of analyzing the data. All right, so our current analytics environments, we basically have two main data warehouse platforms at United. We've got Teradata, which is a sponsor of one of the sponsors of the conference here, and then the Hortonworks platform. The Teradata platform is very mature. It's been in place for 20 plus years. They've got a solid team of people working on that. It's got all the properties of a scalable ACID compliant database, allowing for updates and allowing for large scale data ingestion. Since it's been in place for so long, most of our ETL processes are tightly coupled with this platform. So any organization that's been around a long time, has a lot of legacy. Teradata has been in place at United for many, many years, and it's really the workhorse of the airline on the analytics side. The Hortonworks platform has been around a few years. We consider that emerging technology. Some of the strengths that it brings to the table is economical data science. It's very data lake friendly. The community and support frameworks seem to be changing faster than the more mature Teradata environment. Obviously, log parsing was one of the first reasons that Hadoop was invented. That was one of the things we brought it in initially to do, was to do log parsing. It handles unstructured data and streaming messages very well, and you can apply a schema on read. So these are all properties of the Hortonworks platform that we've been leveraging over the past couple of years that don't quite fit into what the Teradata paradigm. So we've got two data platforms. The big question is, how do we get these two platforms to play together nicely? So further elaborating on the problem, the enterprise analytics team that we have, since Teradata has been entrenched for so long, they're very comfortable with SQL. So everyone knows SQL. Everyone's very comfortable using it. Being able to do analytic dashboarding using SQL, that's all skill sets that we have. The emerging programming paradigms, such as parallel processing and leveraging APIs, not so much. These are things we're growing into, but right now, the majority of the heavy lifting is done using SQL and using the ACID compliant database. When we started using the big data platform, in order to bridge the gap between skill sets, we wind up using high dependency and Hive, relying on Hive quite a bit because it's friendly, makes data look like it's in Teradata. It's very relationally, you can relationally model it. It's very SQL friendly, so that was one of the first things we did when we brought in the big data platform, is try to make it as Teradata-like as we could in order to buy us time to more leverage the more progressive skills of parallel programming and leveraging APIs. So here's a high-level picture of how we're organized. Most of the operational system goes into an ETL process that's tightly coupled with Teradata. Most of the log processing goes through the Hortonworks platform. Obviously, the tools that are emerging on the Hortonworks side will allow us to do more of the processing that Teradata is currently doing, and we can start moving data, right-sizing data between the two platforms and syncing the right data in the right job. So with the two platforms, challenge number one is how do we do data analytics, data science where the data isn't? So back in the previous picture, you saw that a lot of the data was landing in Teradata. However, the compute and the tools for data science are more friendly in Hadoop and on the Hortonworks side. So the question becomes, how do we move the data from the one platform to the other so that we can do data science where it should be done more effectively, more cost effectively than where it resides currently. Two of the biggest data sets we have that we do data science around are bookings and the flight schedule. And as I said earlier, those are all constantly in motion. Every minute, we're getting new, people are switching seats, people are making bookings, the flight schedule is changing, all of that is happening in real time. The problem there is generally the new state of something is equal to its current state plus a change. So what I can't do is I can't say the new information that's coming in overwrites what we know about it already. I have to know what's changing and what the current state of, or the current state that it's in order to make a judgment on what I should do with it. So that's probably one of the most complicated things that we have to deal with on the Hortonworks side is if you have that problem and you've got a fully functional ACID compliant database and can handle that, where you can just do a simple update, that problem becomes a lot easier. However, the update brings the scalability problems. If you've got a fully ACID compliant database, the parallel processing is going to cost more. So in order to do that, we've come up with a couple ways to get around those problems. And these are all things we've got working in different forms here. Obviously, the quickest solution to this is figure out how to get a 24-hour lagging snapshot out of one platform into another. So in order to get these two platforms to work together, you just take data out of one and copy it into the other one. The problem with that is a lot of times in our Teradata environment, it's not optimized for give me what changed yesterday. If you got a 3 billion row table and it's a key value table, and you say what's changed since yesterday, that's going to do a full table scan on Teradata, and it's going to bring Teradata to its knees. So that works in some situations, but not all situations. In small data sets where we can do that, that's a strategy. Another option is, well, if we can't do a scan on what changed in data in Teradata, can we redundantly store the data in Teradata, and in the event, move it from one to the other? Well, that requires additional processing on Teradata, additional footprint on Teradata. We do that in some cases, but again, that's not an ideal solution because it's forcing Teradata to do more work in order to keep the two platforms in sync. What about bypassing Teradata altogether? We move the operational system straight into the data lake. Well, that involves requiring using ACID tables on the Hortonworks side, which is evolving. It's come quite a bit since they unveiled it a few years ago. We do use that, but in some cases, the write optimization, being able to trade off doing the write, will compromise the read. So that's a solution. We use it in certain cases as well. Another problem we would have if we were invoking it straight into the data lake would be, are we able to keep up with the stream? Obviously, Hive is set up to ingest batch, not single inserts. So one of the problems you have to overcome there is if you're streaming to raw, you can buffer and then write to disk. That introduces latency. Or you can stream to disk and then later write a job to clean up the files on disk and compress them into one big thing. So there's trade-offs there as well. The other option would be to stream it raw to disk and then batch process it after it lands on disk. So everything on the Hortonworks side, processing a lot of the data coming out of these operational systems, if you want to keep up, there's going to be a trade-off at this point of the technology. You're going to either introduce latency or you're going to compromise read. That's the conclusions we've came to. We're working with Hortonworks to figure out how to tune this stuff and get it dialed in so that the trade-offs are minimized. But Teradata is bringing properties to the table that aren't on the Hortonworks side. So some things that require updates and require low latency on Teradata, we're struggling to re-engineer on the Hortonworks side. The final thing is pass-through query. I missed this one. This is, you can make a query to Teradata. What if you could make a query to Teradata and Teradata was able to pull the data off of Hortonworks platform and process it on the Teradata side? And we'll talk a little bit more about that on the next slide. That is another solution. However, that still uses Teradata resources. So if you ever worked in a Teradata environment, you start running into issues with spool space, RAM, things that the DBA is assigned to you to use. Data science guys want more resources than they're allocated on the Teradata side. So you run into problems there. All right, so on the Teradata side, the bookings and the flight schedule, it's a mature relational model with heavy secondary indexing. So we use that, like I said, quite a bit. It's tuned on the Teradata side, so we can access it from multiple directions. If you want to go in by a flight, you can do that. If you want to go in by an airline, you can go in by that. If you want to go in destinations, you can go in by that. One possible solution for that we're working with Hortonworks right now to see if we can put all the flight schedule information and the bookings information in LLEP cache. So this is a big RAM cache, Hortonworks side. Can we jam all this in there, and will that solve all our problems? So all we have to do is throw RAM at it, and that'll buy us time to dial this in a little more finesse. Obviously, a booking and a flight schedule data model is a relational model. It's evolved over many years. The question is, can we denormalize it? One of the tenets of the big data platform is taking relational data that's normalized, highly normalized, and can you denormalize it? Well, we're trying to do that. The problem with that is, on a denormalized case, if you take everything you would join to this data set and you bring it into the data set itself, so you're not you're foregoing any joins, there's a lot of data that has to go with these things. If you wanted to put all the passengers that were in a booking, all the members, if you flew with your family of 5, if each one of these people have the associated flight history with them, the denormalized data model gets very complicated very quickly. So completely denormalizing the booking and flight schedule is a challenge. We're addressing that. It's not as easy as it sounds, and it's going to be a problem that's going to have to be solved going forward if we want to take advantage of a lot of the emerging programming paradigms. The Hive concurrency model, another issue, blocking read, or read blocks write, write blocks read. We got a heavy job running on the data science side. We can't necessarily update what's going on the, if the job is running, we can't update what's the job is running on. We have to wait till the job finishes and then we can update it. Or we update and forestall any jobs running on the Hadoop side until the data set's finished being refreshed, and then we can run the job again. The asset tables get us around that, and we do use that in some cases, but not all. Okay, so what is working out of all these problems we've got? What's the cleanest path to getting these two data sources to talk to each other? Teradata's got a product out there called Curated. It allows Teradata nodes to map directly to Hadoop nodes, so that if you do a copy from point A to point B, or you do a query from point A to point B, it bypasses all the internal workings on Yarn and all that, and it's two data nodes talking to each other across the two platforms. We've got the initial version of that tool we've been using. They've got a new version of that tool out, Curated 2.0. We haven't been able to use that yet because our version of Teradata is behind, but we're working on upgrading our version of Teradata so we can refresh to the new version of Curated. This seems to be the cleanest way to get these data off one platform on another via direct copy or via pass-through query. So replicating data from one to the other, we've got 4 or 5 different patterns we found are practical to keep data coming in from Teradata so the data science guys can use it. I've got some of them listed there. Obviously, moving small data sets is trivial. There's no overhead in that. You got a list of airports, a list of aircraft types, whatever. That's easy to keep in sync between the two platforms. Large data sets where the new data coming in Teradata side is append only and immutable. That's case, a lot of data sets fall into that case. We can use Query Grid to keep the two platforms in sync there. That case of that would be What happened yesterday, we append on as a new partition. There's no updates. Whatever happened yesterday, the flight schedule that was completed, and there's not going to be any updates on it. We can pull that over, and the data science guys can then use the Hortonworks platform to do data science. Large data sets where new data changes a small number of existing partitions. We get data coming in where data is partitioned by month, and the data only lasts 12 months versus the entire history of the airline. Only the data lasts 12 months changes. That's a situation where we can keep the two tools and the two databases in sync with the Teradata tool. And then large data sets accessed in a key value type manner, the ACID case. We can keep two tables in the two databases in sync using ACID tables Hortonworks on the Hortonworks side, using the Hive ACID tables. However, we may have to re-optimize that ACID table so that it can be read efficiently by the data science guys. So that may force a repartitioning on the bucketed table. If you have an ACID table Hive side, it's got to be bucketed. It can be partitioned and bucketed. It may need to be re-optimized so that the data science guys can access its Hive side. So this outlines the two paths we just talked about that seem to be working the best, that are buying us time to solve some of these other problems. So replication from one database to the other using Curated, and then allowing the data science guys to access it via Hortonworks using all the resources on the Hortonworks side. The other way was to pass through queries. Teradata, using this query grid tool, it allows you to, if you've ever used remote database linking, the other way you can move data between these two platforms besides just copying it over. If you ever use remote database linking where you have an at notation, select star from database at remote server, works the same way. So in some situations where we're not taxing Teradata, we can allow a Teradata to service the query and remote fetch the data out of the Hortonworks database. This uses resources Teradata side, so it gets used sparingly. All right, so longer term, trying to get the platform independent ETL. We're trying to decouple the ETL from the Teradata platform, but again, proves challenging. One of our allies in that fight is NiFi. We've been using NiFi for stateless streaming, and stateful streaming where latency can be tolerated. So basically the flow we have, if you're familiar with NiFi, the basic flows, a lot of our ETL processes apply to follow the 5 basic steps on the bottom of this. Connect to the queue, grab the data, change it superficially, maybe put an additional timestamp in there, turn it into Avro implementation, turn the Avro into ORC, and flush it to disk. This works very, very well. It's not a very complicated flow. NiFi does this extremely well, and we leverage this considerably. We're going to leverage it going forward even more. All right, so what's not working yet? What still don't we have good answers for? Data sync Teradata to Hive using query grid with large data sets. So some of our data sets are in the billions of rows, and any row in that can change at any time. That's one of the extreme cases we have, but we have several cases that fall into that. We don't have a good way to handle that yet other than decoupling the ETL from the Teradata platform and shipping it over and handling the update problem on the Hortonworks side. The only way we can do that right now is leveraging the pass-through abilities that Query Grid has, using the Query Grid resources in order to service the query. On the platform-independent ETL, streaming stateful messages, I talked about that earlier, being able to decide what to do on a message, what a new message that comes in based on the current state of it. Right now, we've got a lot of custom C++ code that runs on Teradata to do that. That at some point needs to be modernized using some of the more emerging frameworks, and I've listed the frameworks we're looking at to solve that problem down there on the line there. The Hortonworks Dataflow, Apache Apex, Apache Flink, NiFi and HBase, Spark micro batching. These are all ways to maintain state in a streaming situation, so we're looking at them all. Our enterprise message bus has some issues. It's not designed with analytics in mind. All these operational systems that are sending data back and forth to one another, the booking systems, the reservation system, all the operational systems, they're designed to do operational work, not do analytics work. So we're trying to get in with the architecture on a lot of these systems and bring the analytics requirements to the table, saying, look, we need to be able to tap into your message flow, and we need to be able to access it. But right now, the analytics in the enterprise are probably not at the forefront. So a lot of the message traffic. We don't have any kind of schema registry. Most of our messages are in XML and JSON, so the metadata travels along with it, which makes the messages larger and requires more compute power to deal with them on the messaging layer. Other issues we've got, security and governance. I think everyone's facing these right now. Any solution we come up with these, we have to work across multiple platforms. That's the problem we've got. So the common security strategy we're developing in conjunction with the Teradata guys. GDPR is at the forefront right now. That's a very hot topic. We got a strategy that we seem to solve the problem on both platforms. Our strategy is to find groups in Active Directory, assign users to those groups, and then assign rights based on those groups. The groups and users are replicated out of Active Directory to the different platforms, directly into Teradata, and then on the Hadoop side into Apache Ranger. And then the database roles and permissions are defined and can be defined and reviewed on each platform. So that's one of those two problems that we can solve cross platforms using the technology that's emerging. The governance problem is a little more complicated. We're looking for a solution that covers both platforms right now. Apache Atlas has got traceability through Hive, NiFi, HDFS, and the emerging next version will have Spark. This is encouraging, and we think that that's probably the right tool to use on the Hadoop side. We don't have a good solution and that works with that on the Teradata side, so we'll probably have to resort to some custom development using APIs to get around the governance problem. They have one governance solution that covers both platforms. Okay, so this would be the target architecture that's we're aiming for. We've got batch sources in the enterprise message bus. The messages streaming in, those are our two really sources of data. We see those going into one of two buckets, either a stateful high latency tolerant ingestion layer or the stateful low latency ingestion layer, depending on the need. Some of the low latency ingestion solutions out there have an internal state store that they use. Apache Flink is one of those. While it's processing the data on the stateful side, we can query what the state is external to the ingestion layer. So that's got some appeal to it. All data would flow into the data lake, which would be ORC. We're building that around ORC and HDFS. Spark ETL would batch it up to the curated layer, which is a combination, like I said, of Teradata and Hortonworks, trying to pull the ETL data work off Teradata. It would be done before it enters Teradata. So it would enter Teradata clean, pulling the compute requirements off of Teradata. And then that would give us the ability to have a SQL-friendly front end for the analytics KPI dashboarders. And then the machine learning guys can access either the curated layer via Spark, SAS, R, whatever they want to use, or they can access the data lake directly, or they could access the state store in the low latency ingestion layer. Those guys should be a little more savvy about using APIs and have the tools to do it. So if they need the current state of something right now that it hasn't propagated to the data lake or hasn't propagated to curated layer, they can go right to the source of the state management system and get it there. All right, so this picture's drawn a little bit differently, same picture differently, decoupling the ETL from the two platforms, separating it out, the stack that we're building our environment of the future around, and where things land in the path they take to get there. So this is one of the use cases. I got a couple of use cases here I can talk about. This would be one of the use cases that would be made possible on a HDFS-based curated layer. So right now, all the information flowing in about a flight, everything that happens to the flight from the minute it gets scheduled to the minute it lands and it's closed out. Thousands and thousands and thousands of things happen to that flight in different operational systems, okay? We're talking about all the crew assignment to it, all the catering, all the seats assigned, all the, anything you need to do to get that aircraft ready to go, all flows in. If you wanted to store that in Teradata, you'd most likely have to split that up into a bunch of normalized tables and then bring it all back together with a join. And as more data flowed into this, the more costly those joins would cost. So this is simply storing all the information in one place and being able to get it in one pull, and that's possible using Hadoop. So storing this all is time series data where you've got a time event and then a bunch of key value pairs of different items in different states that can all be stored on disk, and that should be in a format that can be set up so that you can say what is the current situation, what is the current state of this flight, and what is all the history involved in that flight, partitioned by different types of things that happen in that flight, either catering or operations or crew schedule or whatever. All that should be able to be stored in one place, pulled in one pull, and you can filter out on the data science level what you are interested in and what you're not interested in. This would be, as opposed to being able to store it in Teradata and having to do all the joins and burn all the CPU cycles on Teradata joining it together. So we think this would allow a lot of new doors to open up on analysis if can capture all this stuff off the operational systems communicating over the enterprise bus, store it in a way that makes sense to retrieve and put it in a format that the data science guys can get at. Okay, another use case would be a trip narrative. This was almost like a flight narrative where we're trying to keep everything that happens together with an aircraft. We're trying to do the same thing with the passengers. So maybe if you go through a cycle of interacting with the airline, you purchase a ticket, you maybe change that ticket, you may change your seats a couple times, you may purchase Wi-Fi, go through the check-in process, get on the plane, buy something, buy a snack box on the plane, land, get your baggage, and fill out a survey. Same idea. We put all that in one place in the data store, and then everyone's history is in one place, and the data science guys can do the customer analysis. We can design the insights that we need to make the customer experience better. And that's it. Any questions? Yeah.
So you mentioned like fuel and altitude.
Or I can repeat it back if.
Yeah, so but you mentioned fuel and altitude and things like that.
Yeah.
So sensor-related data from in flight. I was kind of curious, is that integrated within what you guys are looking at so far? And also, how are you dealing with it in flight, or is it more practical to deal with at the end of the flight?
Right. That all falls under, or the question is, how do we deal with sensor data on the aircraft? Where do we deal it, and when do we deal with it? That fell on the operations part of the data sources we talked about. Right now, we don't have the ability. I don't think any airline has the ability to deal with that any part of the flight other than after it lands. There's too much data, and you can't reliably offload that at any point other than after the plane lands, and it pulls most likely into a Wi-Fi zone in an airport, and it gets offloaded there. We do that a lot with the Wi-Fi data and some of the other data sources. The engine data will most likely have to be offloaded once it gets on the ground at this point. They are increasing the bandwidth between the satellites, but again, getting data off an aircraft in real time is extremely expensive right now. Yes?
So you put the target architecture, which I'm assuming you're still moving towards that,
Yeah.
right? But the other one that you talked about, the patterns for replication as well as pass-through queries,
Yeah.
using query grid, is it in place now?
Yes. We're using that to buy time in order to get to the more complicated target environment. So the stopgap of replicating data off Teradata is only until we can get to decoupling the ETL off of Teradata, which we've got 20 years of legacy to dig through. We think that's the quickest way to placate the data science without compromising the architecture and the development that's done on the platform decoupled ETL.
What has been your experience with pass? How much if you replicate, you don't need to do as much of pass.
Exactly.
So what has
We do both. Obviously, if it's a high value, high hit data set, it makes more sense to replicate it over and use the resources on the Hadoop side. So you gotta kind of make a trade-off to say, is this going to be hit once a day? Is it going to be hit 300 times an hour? The pass-through, we're using version 1 of QueryGrid. Version 2 of QueryGrid is much better. We've prototyped that out. We're going to expand. Right now, we're relying on the replication heavily. We think we're going to expand that to the pass-through once we get our version of QueryGrid Rev 2.0. And we'll start opening that up to more avenues. We have it limited cases now, but most of the way we're using it is the replication model. Yes?
Looks like Spark is your old ETL tool, so how's that been working as far as like development time, governance, and all that?
Yeah, that's complicated. Going from any organization that I think is SQL savvy to a Spark organization is going to take time and engineering, plain and simple. So that is going to probably be the thorniest part of the target architecture is relying on that. Again, we've got some time. We can pick and choose what we think we can get done in Spark based on our skill set and based on what problem we have. I don't know if we'll ever get to the point where everything is in Spark, but right now that's a lot of the data sets we have. The programming model fits, and we just have to figure out how to get it in there. So I don't have an exact way to answer that question other than a case-by-case basis, deciding which route to go.
Have you looked at any ETL tools which can generate Spark code for you instead of you writing it?
No, we haven't. That's probably something we should do. Most of the Spark program we've done is we've got 3 or 4 patterns identified. Ingest data into a data frame, manipulate the data, write it back out. 3 or 4 simple things like that we're trying to nail down. Once we master the basics, then we'll start getting the more complicated ones. We have not looked at any frameworks that generate Spark code, but that's certainly, we just haven't done it. I don't think it's a bad idea.
And your ETL, do you have a lot of complexity in transformation? Do you need to kind of join a lot of things to do transformation, or it's fairly simple?
Yeah, absolutely. You think anything in an airline, everyone wants to know what the weather was like when they were selling club passes. I don't know. It's any permutation of any data that somebody will want to know, it will require some convoluted join to get to. So yeah, all over. That's why we really can't denormalize things, because you'd have to put everything in one place, and that's not practical. Yes? So right now, we've been trying to project that out based on the rate we've been going. We probably think it'll be 4 or 5 years before we have a completely decoupled ETL architecture. I don't see it being done any faster. I don't see throwing more resources at it making it any faster. I think we have to go through this and do the complexity of the data and the complexity of the environment. An airline is a precision machine, and it doesn't thrive on change very quickly. So I plan on a longer rollout for this, a more careful, deliberate rollout, rather than a crash program just to say we did it. Yeah, it was one of the things we're looking at is HBase. In fact, I think the last couple of days here have reinforced that. I didn't hear as much HBase talk at this last year, but this year I'm hearing a lot more. And I want to reach out to some of the people that have talked, some of the talks I've went to, where they are using HBase in an operational setting to do stateful management. Anything else? Okay, well, thank you.